Hello friends. So you might be wondering why I'm showing you this heating rod and boiling water. Well, I was quite curious to know about the modes of heat transfer and how the heat is transferred from this coil to water. Well, to understand that, we have to first understand the method and the mechanism of heat transfer. Well, heat always flows from body at higher temperature to the body at lower temperature by the virtue of temperature difference. That is how heat transfer takes place. Well, another approach towards heat transfer can be understood by the molecular arrangement of the material. Well, we can see in solids the particles are very closely arranged, but in liquids they are quite away from each other, and in gaseous they are far away. So heat transfer by vibration is only possible in solids and not in liquids and gases. So we can now see different methods of heat transfer. Going with the very first, there are three methods of heat transfer. The first one is conduction, the second one is convection, and the third and the final one is radiation. To go with the very first method, conduction, let us now see a rod in which particles are very closely spaced. The rod's cross section is area A and the two faces are at distance D. So now let us now use a candle to heat the rod from side A. And now after a certain while we will be seeing that the molecules will be starting vibration about their mean position. So after setting up a temperature gradient, a conductive current would be set up in the rod, and this is how conductive heat transfer takes place. So now let us see exactly the definition of conduction heat transfer. Well, it is the process in which heat transfer takes place from particle to particle without any particle leaving its mean position, but vibrating with amplitude which depends on its temperature. For conduction, friends, the medium is actively involved. I am saying the medium is actively involved because in gaseous states, in radiation, the medium is not actively involved. So what are the different examples? So the substances which carry heat are good conductors of heat. So they are called as good conductors of heat, that is metal. The second, the substances which do not carry heat through them are called as bad conductors of heat or insulator. For example, wool, cork, wood, rubber. So these are the examples of bad conductor. So what are the factors that affect the conduction process? In a steady state, the amount of heat Q transmitted through a conductor is directly proportional to the temperature difference, the area of the cross section of the rod, the time for which the heat flows, and is also inversely proportional to the distance between the two faces of the rod. So these are the factors which governs the equation. So depending upon these factors, the governing equation for heat transfer can be given as Q is equal to K AT theta 2 minus theta 1 degree Celsius upon distance D. So you might be wondering what is K. So the K here is the constant which is also known as the coefficient of thermal conductivity. Well, to define the coefficient of thermal conductivity, it is the quantity of heat flowing per second across the cube of unit age when its opposite face have a temperature difference of 1 degree Celsius. Well, the unit of thermal conductivity is calorie per centimeter per second per degree Celsius, or watt per minute per watt per meter per Kelvin. The dimensional formula for thermal conductivity is m raised to 1, L raised to 1, T raised to minus 3 and K raised to minus 1. Well friends, this will be important for you for the JEE preparations. So that was all about conduction. So now seeing about the next process, that is convection. So what is convection? Let us assume a vessel in which water is placed in normal room temperature. Now let us heat this water from the bottom. After a certain while, we will be seeing that the particles in the bottom will start rising upwards slowly. So this is because the particles when heated becomes lighter and expands, and they experience a greater buoyant force towards upward direction, and thus they come up, and thus a convective current is set up, due to which convective heat transfer takes place. So going in specific manner, definition of convective heat transfer is transmission of heat from one part to another by actual transfer of particles of matter. Here also, again, as I said in conduction, the medium is actively involved in convection. So there are different examples of convection in environment, like a wind is a convection current in the atmosphere caused by the unequal heating. Another example is trade winds and the monsoons are convection currents on a global scale. So going with the different types of convection, friends, basically there are two types of convections. First one, free convection or natural convection. This is a process of convection which takes place naturally without any external agency. And the second one is the forced convection. Well, forced convection has to be initiated by the help of an external agency. The convective current here has to be set with the help of a pump, generator, or some agency that would help to initiate the process. So this was all about the free convection and forced convection. So there are different examples of free convection and forced convection in an environment if you observe. So that was something about convection. Now the last one, radiation. What is radiation? Now let us see the example of sun, earth and the atmosphere cover. Friends, beyond the atmospheric cover, there is no medium to transfer heat. But again, the radiant energy from sun reaches to the earth. Well, why this happens? This is because the process of thermal radiation. Yes, thermal radiation is something which does not require any material medium to transfer heat. So to define thermal radiation is the process of transmission of heat from one place to another without actual material medium. And as I said, for conduction and convection, that medium is actively involved. Here the medium is not actively involved. Example, we just now saw the energy radiated by sun on earth without any material medium. So that is something about radiation which does not require material medium. So going further, let us now see what are the different properties of this wave. This radiant energy consists of a long wavelength whose wavelength ranges from 800 nanometer to 400,000 nanometer. It generally occupies the infrared region of the electromagnetic spectrum. It can be transmitted through vacuum at the speed of light. It obeys all the laws of reflection, refraction, interference, polarization and diffraction. It also obeys the law of inverse square law. Well, the radiant energy depends on certain factors. These factors are the nature of the surface of the body, secondly, the surface area of the body that radiates energy, and the temperature of that body which radiates energy. It does not depend on the body that absorbs energy. It depends on the body temperature which emits energy. So, going with the very flow, let us now see what is emissive power. Emissive power is the energy emitted per second per unit surface area of the body at given temperature for given wavelength range. This is called as emissive power of a body. It is the capacity to emit power at a given time and temperature. So the SI unit of emissive power is watt per meter square, and the dimensional formula is m1 and t raised to -3. Friends, you should always remember the units and the dimensional formula since they will help you for the... So friends, going with today's final concept, that is emissivity. It can be defined as a ratio of radiant energy radiated by the surface of a given body to that of a black body. It is nothing but the measure of emissive power of a certain body in relation to that of a black body. In general, emissive power of a black body or emissivity is 1. So friends, now let us revise what we saw in today's lecture. Conductive heat transfer. What is conductive heat transfer? Transfer of heat from particle to particle by vibration of particles about their mean position and not actual migration. What is convection heat transfer? Transmission of heat by actual migration of particles. And what is radiative heat transfer? Radiative heat transfer is something which does not require any material medium. Well, in conduction and convection, the medium is active, while in radiation, it is not active. So that is something that we saw today. So friends, these are the basic concepts of heat transfer that are necessary for various competitive exams. So do like and subscribe my channel for more educational videos. Signing out, Gaurav. Thank you.